So the life cycle of a star. Please remember that our sun is a star, because lots of students get confused on that, and it's a common exam question that they pop in to just test your knowledge. Now, how do stars actually, how are they formed? So we're going to have a look at the stages, because the universe does contain billions and billions of stars, and our star is only an average star. Some are smaller and others are much bigger. Regardless of their size, all the stars are formed in the same way. They start off with a huge cloud of gas, mainly hydrogen, called a nebula, which begins to be pulled together by gravity, and a large ball of gas forms in the centre of this cloud. As it gets denser, more gas is pulled in, and the ball gets hotter and hotter until it forms a protostar. So let's have a look at some examples of a nebula. This is the actual startings of new stars that some scientists have actually taken photos of. Okay, so as I said, we get to the stage where it becomes a protostar. So gravity will slowly pull all the particles together, and as they move inwards, their gravitational potential is converted into heat, and a protostar is formed. This continues to grow larger, and eventually it gets so big and its centre gets so hot that atoms are squashed together in a process called nuclear fusion, and a star is now born. So the energy released in nuclear fusion pushes out against energy and keeps the star stable. Okay, so we have a look. This can last for billions of years and is described as the main sequence of the star, and this diagram will show you what we're talking about. In a main sequence star, the forces of attraction pulling the particles inwards are balanced by the forces acting outwards due to the huge temperatures inside the star, and that's really important to remember. It's the balancing of the forces. Stars are basically nuclear reactors that use hydrogen as a fuel, and during its main sequence a star will release energy by converting hydrogen and helium into the heavier elements. Now, our sun is an example of a main sequence star, and we think it's in the middle of a 10 billion year lifespan. So it has probably about another 5 billion to go before it starts to die, so you'll be quite safe. Okay, so what happens after this thing? Now, this is where we can split into two stages. All stars eventually die, but what happens to them depends on their mass. Small stars, like our sun, and we think ours is a small star, gradually cool and expand to become a red giant, as you can see at the top. The outer layers of the star break away and form a planetary nebula. All that remains is the white hot core of the star, and this white dwarf gradually cools over time. Now, if we've got a larger star than our sun, they have much more dramatic lives. They too eventually expand and cool, but they grow much bigger and they turn into super red giants. The star then explodes in a gigantic explosion called a supernova. So we can see for the small stars, then they go down into a white dwarf, and then they'll just basically burn out into a black dwarf. But with the red supergiants, they will shrink and then explode. It's because they get so heavy on themselves, they actually implode and then explode, releasing massive amounts of energy, dust and gas. Okay, and there you can see. Now they turn, this star then explodes into a gigantic explosion, and this is called a supernova. And I'm sure if you remember the Oasis song, Supernova, maybe help you remember. When a star goes supernova, it often outshines all the other stars in the galaxy put together. During a supernova, the core of the star is crushed down by immense gravitational forces, and this can form a very dense kind of star just made up of neutrons. This neutron star spins very fast and sends pulses of radio waves to the Earth. If the star is even bigger, the core is crushed down into a tiny space, and this forms a black hole. Black holes have gravity so strong that nothing can escape from them, not even light. Okay, they have near infinite densities due to their tiny volumes. All the mass of the core is crushed down into a space smaller than an atom, and if you get too close to a black hole, you will be pulled in, and the gravitational force is so large that you will be squished. And there's some examples. Okay, if you just look then at second generation stars, you will see this is what can happen afterwards.